welcome you to the museum. Thank you for giving up your time, your energy, and your wonderful knowledge to share it with our people here and our visitors. Thank you.
Thank you so much, Marisa. Tēnā koutou, tēnā katoa. Again, thank you from the Canterbury Museum for actually giving us the opportunity to kind of like do this. And we hope that you learn a little bit more about the moon after this talk. So just a little bit of introduction to ourselves. So I'm Emeline, that's Eric. As you can see, we're a couple. And we've been here in New Zealand for 3 years under the Edmund Hillary Fellowship. We came from California, although I'm originally from the Philippines as well. And Eric, you want to talk about your background?
I'm from the U.S. and I started in physics and astronomy, and then went into space engineering, and I worked for NASA on space station design for about 8 years, and then some of the lunar mission planning, and recently involved with commercial lunar missions with 3 different companies, and before coming here with the as part of the space bases.
And so my background is a little bit eclectic. So I started out with physics and space science as well, so more technical background, but then I moved into space education, so program development and operations, working to start up a master's program for the International Space University. Then I moved over to space tourism, which I'll talk about a little bit later on. No, that's not in space. It's on the zero gravity Vomit Comet, and I can talk about that later as well. And then the most recent one is I'm really more focused on space entrepreneurship and helping space startup companies, especially when we were in the US as well, to kind of like start that new space. And we're here in New Zealand, as I mentioned, with the EHF Fellowship, and we started this company. It's a social enterprise called Spacebase, and our focus is to help New Zealand catalyze the space industry here. When we were here, Rocket Lab and the New Zealand Space Agency was still beginning. So I will.
Great. I'm going to zoom through a lot of material, partly about the moon and properties of the surface and things like that. Talk about past missions and Apollo, and then planned future missions, and then talk about what it would be like to fly to the moon on one of the vehicles being designed now. And then Emeline will talk about lunar tourism and also about how New Zealanders are getting involved in it. So here we have the moon near side and far side. What's interesting to me is that when I was born, no one had ever seen the far side of the moon. It was only after I was born that a Russian probe went and took the first image of the far side of the moon. And my parents gave me this moon when I was a kid, and it even has an unknown region here where it had never been photographed. And so this is, and I saw this in the Smithsonian Museum. I was like, I have one of those. Yeah. So this was what was known just before Apollo was just beginning exploration of what the moon looked like. And as you can see, that the moon near side and the far side look different. The near side has all these flat lava plains, and the far side is mainly just high mountains. And here's the scale of New Zealand with respect to the moon. So you can see that it's people refer to it as another continent in terms of land mass. So the moon, this is what the moon looks like relative to the Earth. That is actually very dark gray, dark brown color compared to the bright blues and white with the clouds on Earth. And so, no matter what you think of how bright the full moon is, the full Earth would be, if you were on the moon, would be 30 times brighter. And so it would be just dazzling to look back at the Earth. This is the moon, Earth and moon to scale. And so this is actually how far apart they are in relative to their size. And this is the speed speed of light between them. And so if you try to have a conversation with someone out at the moon, you have to basically wait, more than 2 seconds to get your answer to your question. And so it really makes the conversations with astronauts on the moon kind of a challenge. You basically just talk a lot and then say over and just wait for a reply. This is a view when we see the moon during the month changing phases like this. From the, if you were on the moon, you would see the Earth with an opposite phase, as this becomes full, on the view from the Earth, from the moon, you see it in eclipse. And so it's, some people have said that if you're on the moon, if you looked at the Earth, if you saw what part was seeing sunrise, you would be able to tell the local time of, it's like a giant clock in the sky, if you're looking back at the Earth. So there's, this is a summary of some of the past moon missions, especially from the Soviets and the U.S. before Apollo. There's a lot of robotic landers all around the moon. And so there was a lot of activity up through the Apollo missions, and then there was a long gap. And there are a lot of orbital missions, but only a few landers since then. And so the Chinese, for example, landed here, and then they landed on the other side just recently. And this is Apollo 12 landing near Surveyor 3. It's the only case of one lander landing near another one. So we have the human lander landing a year and a half after the robot landed over here. And recently, in the last couple of years, it's become more important realizing how much this landing here blasted this lander here, with hitting it with rocks moving at a kilometer a second, sort of like a scatter of machine gun fire from this landing over here, hitting this old robot. And so where people are beginning to realize that landing next to each other is going to be a big problem on the moon. And I'll talk about that and why New Zealand might have a solution to it. So with the Apollo missions, sending humans to the moon back 50 years ago, there were 6 landings on the moon. And the giant Saturn V and the humans were just driving up here with the lander right inside. So it was enormously complicated missions. One thing that happens with, if you're going to the moon is basically orbiting, and you're reaching up as high as you can with the energy of the orbit, and you're basically letting the moon run into you. You have to time it just right so you can capture right on the other side of the moon, and all the critical maneuvers for Apollo happened on the far side of the moon, and so out of communication of the Earth, and so here's all the critical maneuvers that were going on, where firing your engine to get into lunar orbit or to get out of lunar orbit and come back to Earth. And one person I communicate a lot on Twitter with is this one woman that was in mission control, Poppy. She was an expert at getting humans back from the moon during Apollo. And what was interesting to me is that she would be the person that would be monitoring the communications, and when she saw the data from when the vehicle came around and became visible from the Earth, she would know instantly, looking at the numbers, whether or not the astronauts made it and were headed back to Earth, or if they were had not succeeded, and whether or not they were going to be alive or not. And so it's just amazing to me that there were 100 million people watching what was going on, and she was the only one who knew the scorecard. And so it was everybody in mission control was waiting for her to just tell them whether or not the astronauts were going to make it. just at the limits of what you could do in the 1960s. You had people flying out to the moon, spending 3 days going out in something about the size of a closet, and landing on the moon in another thing that's about the size of a closet for only 2 people, staying up to 3 days on the moon, and then coming back 3 days in the command module. With the Apollo missions, 11 was the first one, 12, 14. These were near the equator. They thought they could only land near the equator. Then they got more sophisticated and started going off the equator into the mountains, 15, 16, and 17. So this was Apollo 15 off in the mountains, and they started being able to carry this Lunar Rover car that basically was folded up on the side of the vehicle, and you could unfold it and pull the wheels out and get it to run. And the Lunar Rover, the electric Lunar Rover, they say that it would work fine if you just brought a new battery from Earth. It's sitting there waiting for you. So here's when the Apollo astronauts realized that the moon is 1/6 gravity of the Earth, they thought, oh, that's great, we're going to be bouncing around. But the spacesuit engineer said, oh, we can make the spacesuit 6 times heavier, and the astronauts can handle it. So they made 80-kilogram spacesuits, and so those poor astronauts could scarcely move around with this. They tried to, if they fell over, if they ended up on their back, they were like a turtle. You couldn't get up unless they got help. So the astronauts tried every different way they could think of moving around. I like the idea that he can't possibly bend down and get this thing, so he has to use a scoop. And then now he needs help for somebody to hold the scoop. And here's the Lunar Rover vehicle where he was just demonstrating on Apollo 17 how fast it could go, kicking up dust. You can see the dust flying in 1/6 gravity. So they really loved the Lunar Rover, but they also didn't trust it. They never drove any farther than they could walk back to the lander, and so that's one thing that sort of can put a constraint on how far they could explore. So here's their tracks based on, if you started at the museum here, the Apollo 17 got all the way to the coast, and also the Russians also had robotic landed driving vehicles, and so they got their robotic vehicles. So this is a zoom in on Apollo 17 landing site that shows the longest surface exploration for the Apollo program. You can see, even though they went 11 kilometers, it was still a tiny part of the moon that's been explored. And this, the Lunar Orbiter now that made the map that's in the exhibit can take an image and see the lander there and see the rover waiting for a new battery over here. But it just shows you how tiny bit of the moon has been explored by the Apollo. So the Chinese currently have one operating lander and another operating lander and rover on the far side of the moon. And so they're the only ones that have landed anything on the moon in 50 years. And so they are, this one is still operating it's been going on for a year. Every lunar day it drives a little bit more. And so they've just published some results yesterday about the subsurface radar that they're using. Israel, a nonprofit group, tried creating a low-cost lunar lander, and they got so close. They took this one image just before landing, and it crashed in the last 2 minutes. It was really unfortunate. When you're trying to land with a robot, you're trying to do all the sensing and radar and looking for boulders to not land on boulders, and everything, it all came together except they accidentally rebooted the whole system. And so they were trying to restart the lander, the computer on it, just as they hit the moon at 600 miles an hour. The Indians also, they had a lander and an orbiter. The orbiter is working fine, but the lander also crashed in the last 2 minutes. So not good luck for these two things. There's also a local company, Chicks, that made this very cool augmented reality system for the iPad or other Android systems. And so it's, if you search for ISRO Moon Mission, it's a free app you can download and select the mission. So just recently, there's been lots of activity getting ready for moon missions, mainly for NASA and Europe have big projects, but Russia, China, and India and others have also big plans. There's this, I don't want you to read all this, but it says there's 95 missions planned in the next 10 years. After this long period of almost no missions. And just on the US one, this is the plan for when humans will land on the moon again in 4 years. But one thing I wanted to point out was that the first mission on the US side is actually launched by Rocket Lab. It will be launched from their New Virginia launch site. And it's going into this to demonstrate this really bizarre halo orbit around the moon, which is where the space station, the moon space station is planned to be built. And I just wanted to point out that the moon has a very interesting gravitational field with respect to orbiting around the Earth, so that there are actually stable points in the Earth-Moon system. And you can actually orbit these stable points, not even orbiting the moon, but going connected to these other points. And so that you have this navigating around the Earth-Moon system is very interesting. It's not just simple circular orbits. It's you actually can bounce around between these different stable points. NASA is supporting a lot of these commercial activities with these something called the Commercial Lunar Payload Services, and so a lot of these companies have been qualified to attempt to deliver these landers on the moon. For a while, Moon Express, I was a project manager for this back in the early days, and we were going to try to launch on a Rocket Lab Electron, but then the spacecraft got too big, and so now it's another big launch vehicle plan. But some of the robot missions for commercial providers are being supported. Astrobotic will be launching next year, and Intuitive Machines as well. Here's some of the landing sites. The proposals for this site just went in, and this one was announced today. NASA is opening the competition. So it's the NASA is helping, spur a lot of commercial activity so that people can, if you want to have a payload, you can deliver to the moon. You can do that with one of these commercial companies. As NASA is getting ready for the sending humans to the moon, they have this design competition now going on for a lunar lander. There's Jeff Bezos with his design for a Blue Origin lunar lander, and here's the Blue Origin lunar lander with a Lockheed part on top. Here's the Dynetics version design with compared to the Apollo vision, and then boom, there's the giant SpaceX lunar lander design. So SpaceX thinks they can deliver this entire vehicle, which can actually carry up to 100 people at once to the moon. And so this is the part I'll show you in a little bit about what their plan is. You can't read this chart, but I just want to say that it's very rare for NASA to finally admit that they don't know everything, and I just have to capture these charts when they show it. And so there are a lot of things like food and nutrition and health and logistics, even monitoring fires and board that NASA really doesn't know how to do. And so every once in a while NASA will ask and say, please help us. I wish they would do that a lot more. But so there is a lot of opportunities for people to work on different pieces of this. Now I'll tell a little bit about some of the interesting features on the moon. This image was taken just on Saturday by this astrophotographer who stretches the colors. Those are real colors, but enhanced. I mean, like stretched so that you can see the subtle blues and browns. So the titanium areas show up a little bluer. You have this is measuring the depth of. These mountains are as high as Everest, and these are almost as deep, 8 kilometers deep. And so there's extreme variations. This area is the biggest impact crater in the solar system. It was only realized that it was a crater after some of these measurements were coming back. The craters, these are really tall mountains. Those are 2-kilometer tall mountains there. But one thing that's very different about mountains on the Earth and versus mountains on the moon, like a mountain on the moon, Earth may take millions of years to, through earthquakes, be lifted up and get higher and higher. Mountains in craters happen within the time period of this talk, and so it's within an hour. After the impact of a giant asteroid, it will melt the whole region, cause these mountains to leap up in the air, and so you have all these records of extreme violence that happened billions of years ago, and then was frozen in time. And so that's the amazing thing about the moon is you go to there and you see this evidence of incredible violence that happened in the distant past. These craters, for example, are 50 times older than all of New Zealand. They're 3.5 billion years, 4 billion years old. And here's the center peak of Tycho crater. And what I like about this is this boulder right here is actually larger than the museum. Here's the museum, our museum to scale with the boulder. And so here's a video zooming in on this Tycho crater and showing the boulder at the middle of the crater. This also happens to be the crater that in the movie 2001 they found the alien monolith buried there. It's a Tycho magnetic anomaly 1. So there's the boulder right in the middle. And so no one is quite sure exactly how that boulder ended up there, but it was just basically jumped up in the air 100 million years ago. Tycho was one of the younger craters. I'll mention a little bit about the most valuable real estate in the solar system, which is this part of the rim of Shackleton crater. Here's the edge of that. Let me go ahead and show here's the surface water ice that was recently discovered at the South Pole. There's South Pole and North Pole have water ice because some parts of these craters have not seen the sun for 3 billion years. And so Shackleton crater is very deep. It's several kilometers deep. So if you go to this, here's some of the water ice. So it's about 10 times as much water as in Littleton Harbor. So it's not, an infinite resource, but it's enough to get support lunar bases. It's more enough to turn into rocket fuel and support Earth-Moon transportation system. So here's the rim of the crater. The rim stays in sunlight while the crater is in shadow. And so 6 different countries and 9 different companies all want to land on that spot. It's only recently realized how they cannot land next to each other without damaging each other. So that's a real challenge. It also, the lunar day on most of the moon is like 130 degrees centigrade, and lunar night is minus 170. And so, but there's a little band around the poles that is a really pleasant degree temperature, and except for in the deep craters, which is an extreme minus 230 centigrade. So that's why there's a lot of interest of setting up bases at the poles of the moon. But another alternative is to go under the moon into these lava tunnels, lava tubes that were formed billions of years ago. It turns out lava tubes on the moon can be maybe a kilometer across, and so it's just perfect for, once again, the movie 2001, enough to have huge structures inside. So this is a vehicles being built. One of the large vehicles being built right now is by SpaceX, called Starship, and they're just testing hopping components of this vehicle in Texas right now. But the plan is to build these, what's called the Super Heavy and the Starship on top, and they think if you refuel it in Earth orbit, you can go out to the moon and carry 100 people. And so this is an idea of what it might be like in a few years to be able to go to the moon on a Starship vehicle. This vehicle inside is about the size of this room. So it would be, you would basically, they have designs for having individual cabins for your flight, for your 3-day mission to the moon. And the key is the reusability of, like for example, the booster, the Super Heavy booster comes back and lands on the landing pad, ready to be refilled and reused. So that's so instead of Saturn V cost $1.5 million to go to each Apollo mission, Elon Musk has a target of $7 million a flight, and so that's about first-class tickets around the world, kind of. So it might be possible to get a ticket to go to the moon, or be one of the people going to work on the moon. So here's the vehicle after being refilled by another cargo vehicle and then heading out. And this is so the vehicle, you can see the windows on the side with the, so you have potentially 100 people with their cabins. And it still takes about 3 days to cruise out to the moon, but you do have incredible windows to look out of rather than the Apollo ones, which are about that big. Once again, the typical thing is to get in front of the moon, get captured, go around, see Earthrise, and as you're captured in lower lunar orbit, and then get ready for a re-entry burn, or a landing burn for the descent to the surface. Back in Apollo days, the computers were not sophisticated at all, and so it was really humans needing to pitch over the spacecraft and look down the ground and steer the landing. Whereas this has, besides having the automated computer systems. Also, NASA I tried out a augmented reality system where you look down with your goggles and the vehicle seems like it's transparent, so you can see you don't have to have the cockpit pointed at the landing site. You can just look down at your feet and see the landing surface. So here's the 200-ton vehicle landing on the moon, kicking up a terrible amount of dust. And that's, it's only recently realized that we really need landing pads for, like these little things for landing big vehicles like this. And one thing that Emeline will mention also is there's a group at University of Canterbury that's working on Lunar Concrete with Professor Alan Scott, and that may be an important solution for what's needed for structures on the moon. And no one has had pressurized large volumes in the moon with 1/6 gravity, but we should have them in the future. Lunar architecture is kind of interesting. You don't need stairs. You can actually jump from floor to floor, and it's appropriate we're in the bird hull because on the moon, with a pressurized atmosphere, you can strap in wings and humans can actually fly. So that's it's interesting to think of all the things that might be different if you're in low gravity on the moon. So, Emily will take over.
So I'll just add a little bit more on the human missions and what's happening today and what we could potentially also participate in. So Eric talked a lot about Apollo, and Apollo was a very inspirational program. I mean, from start to finish, it was like 10 years. And it inspired kind of a whole generation of people. And so at that time, like the 1960s and early 70s, when the program ended, we thought that, in about 30 years' time, we're all going to be going to the moon already. And so during that time, there's an airline called Pan Am, which probably can compare to Virgin Atlantic today or Qantas or whatever. They actually issued, first moon flight club where you can actually make a reservation, and there was about 93,000 people who had received this card, which they were claiming that they can actually send people to the moon by 2001, which, if you remember, like Eric talked about the 2001 Space Odyssey movie. But unfortunately, that actually never happened, and there's only been 24 really humans that have gone beyond sort of like Earth orbit and has gone to a place that's an extraterrestrial body. So it's not until 30 years after this, so 1968 to fast forward 1998, there's a company called Space Adventures that actually started, and they have been sending private citizens to the International Space Station if you have like $50 million. So it was fortunate that I was actually recruited to be part of this startup back in 1998. And so yeah, for 50 million, you can actually go to the station. But at the same time, they also had this circumlunar mission, which if you go to the website, is still there. Way back in 2006, this was already available. So they were hoping that Soyuz rocket, which is the same rocket that brings up astronauts and cosmonauts today to the ISS, can be used to do essentially an Apollo 8. So it's like circumnavigating to go to the moon and back. Not landing, but to go to the moon. And so this is still an opportunity. You can go to the ISS for 10 days, and then after going to the ISS, you actually go and do this circumlunar mission. Right now, I don't remember how much it is. If I remember correctly, before it's about like $200 million. So that's an option, but again, since 2006, nobody has actually made a reservation. And it's not only until like 2 years ago when SpaceX announced that this Japanese billionaire who actually put a deposit down, and for Starship in 2023, he's gonna go and he wants to take about 6 to 8 artists with him to go on essentially again an Apollo 8 mission to the moon, but not landing. Just like last January, he has this announcement that he wanted to do a reality show to find kind of like his partner to actually go on the mission. But again, I think that also changed, and I don't know if he's doing the reality show anymore. But that's certainly something that's happening today. So, but the next question is like, so yeah, this is the guy, and yeah, the applications originally was January 17th. But the next question is like, but when do we go? So those are basically millionaires that have a lot of money, but when do we, as just like regular people, will be able to go? And really, it's much nearer than most people think. And so just this year, what is really the most important thing to actually make that happen is that you need to have a reliable private transportation system to get there that's private. And then also potentially a destination or like a habitable destination to be able to bring people there to either settle or stay. So this year alone, SpaceX with Dragon, it's the very first really private company that has been owned solely by a private company. And so that gives a lot of opportunity, not just for government missions, but also for private missions that could have like the moon as potential destination. So that's one thing, and also the fact that SpaceX now is working on a test vehicle. I'm sure you've probably seen just recently this. It looks like a water tower that's actually doing hops. So that's like the first step for their vehicle development. And then the other thing is, this is just, I think of just a few days ago, where now the engines for the lunar vehicle has been just delivered to California. So it's happening. The thing with Elon is that he normally has a problem with actually pinpointing the right time. But once he's actually said that he's going to do something, it's going to happen. We just don't know when, but it normally will happen. So the other thing, as I was saying, you need to have like an actual habitable module or settlement to actually go there. And so Bigelow Aerospace is another company that's been around for a while. Back in 2005, 2006, they've also already launched a prototype of this inflatable modules in space. So the technology is there. They've just been waiting for the right transport system to actually happen. So this one's, I think, the Olympus module that it's in their warehouse. But unfortunately, because of COVID, actually Bigelow laid off all of their employees like around the March timeframe, but they said that they're going to start back up again once the pandemic actually finishes. So we don't know when that is, but for sure this is already something that is happening. So going to New Zealand, Eric showed this photo earlier. So we overlaid some of the things that are already happening actually today in New Zealand. That is working towards potentially these missions for the moon. So one thing that Eric mentioned is that the lunar landing pads are really important, and so if you can create the landing pad of which being able to actually produce a landing pad and cement on the moon, that's a really critical point. And so the Department of Engineering in UC is working on this. There's also, of course, with Christchurch already being a kind of an expert in logistics and operations for Antarctica, it's an analog for being able to do this as well for kind of like for the moon. Food production, University of Canterbury is also working on essentially how do you produce like pharmaceuticals and medicine and food for long duration missions, and so that's happening today. In Auckland, there's a company called Extraterrestrial Power that wants to create energy and basically solar panels on the moon using in situ resources, and so that's also being worked on. And then Eric talked about Rocket Lab's mission as well as a precursor for all of these missions that are happening. So the last bit is like, how can you get involved? One thing that is really important today is that, you know, when we talk about the space industry, it's no longer just the rockets and the rocket ships or the big missions that are really expensive. Everything along that supply chain, from food to education to manufacturing, robotics, all of these are part of the space industry. And so one way to think about this is that the space industry is really just an extension of all of these terrestrial industries that we already have applied to extreme environments. So if we have that as an analogy, some of the examples here, so we talked about, you know, robotic missions that are big and expensive today, but the trend really here is that before we can settle on the moon, there's going to be a lot of these precursor missions, and there's going to be a lot of like this small robots that will be populating this extraterrestrial sort of environment to lay the foundation for humans. And so robotics today, terrestrial robotics and technology is about the same way as you kind of like look at the lunar robotics that's going to happen in the next few years. Digital manufacturing, so 3D printing today is becoming ubiquitous for us as well. And it's really, really important because in the future, we don't want to be launching everything that we need on the moon, which is why it's really expensive. We need to be able to manufacture things using resources on the moon. So it's, again, same technology as digital manufacturing for terrestrial applications. Here's another really, really low-hanging fruit. What we need for settling the moon as well is to be able to create our own food and manufacture food like in space. So today we have different techniques like hydroponics and aeroponics and vertical farming that again are still the same type of things that we would need for settlements in space. And then last example here is this is another niche market that hasn't really been fully looked at much. We still have very much the same kind of like spacesuits that we have for decades. And today, terrestrially, we're exploring and looking at, you know, smart wearables and smart textiles that can lead to potentially looking at the new generation of like spacesuits in the future. So I'm going to end there, and really for us, we're in this really exciting times. In the not so distant future, we hope that this is going to be a scene where you go look at the moon and you see actually lights there, just like you see lights on Earth, during nighttime, where there will be people that are permanently settled there, and that we're going to have like an Earth-Moon sort of like community that just basically thrives for the sustainability of planet Earth and also the Moon. I think I'll end there and we can just do questions. But actually, you have some more Moon.
Well, I just have, all I have is one. Well, by the way, our charts are on this bit.ly address if you are interested. And then this is just a view of what the Moon phase is right now, which is it actually at this phase it's rising at midnight, so it's early morning. But this is a snapshot from. There's a nice part of the exhibit downstairs that has this showing the phases through the months. So yeah, that's it. So I think we're ready for questions if you have.
Yeah, so just going into outer orbit with Sophia, or going to Antarctica is physically demanding and psychologically demanding. So what are the physical requirements going to be and psychological requirements going to be for allowing people to go to the moon? I'm sure a lot of people want to go, but the reality is they're going to get to a place of limited resources and it's going to be physically demanding.
Yeah,
So how are they going to screen for that?
Yeah, I think it's going to be. It's definitely going to be a transition in time. It'll start, like you say, it'll be. It's really going to be like an outpost, and really demanding, even if it's a commercial enterprise or just like there's equivalents of oil platforms or things like that. But I think it'll evolve to be more like accommodating to visitors, and so it's interesting also to read about how miserable it was in the early days of aviation. All these people tried to smile because they were coming off in, it was $20,000 to fly across the country, but they were bouncing around and their toilet was just a hole in the airplane and things like that. It's just, so they were, so even the accommodations got a lot better over time for just long distance travel. And so I think similar kind of thing is for going to the moon. It's also interesting with Antarctica that there was also a sort of a 50-year pause between 100 years ago when first, 110 years ago when the first expeditions to the South Pole were going on. Then there was a long pause, and it wasn't until the aircraft started being able to deliver people that you really got a boost in scientists going to Antarctica. And so I think it's sort of similar. We've been waiting for a long time between Apollo to now to be able to return to the moon, and we're just at the verge of these large-scale, lower-cost vehicles that are enable the next jump in activity.
And maybe just to add as well, at least today in terms of like the space tourism type of programs, they do actually account for a lot of this sort of like terrestrial training. So even Virgin Galactic, for example, now which is only doing like suborbital flights, they do have a program where they would have to make sure that not just you're physically able to do the flights, but that all of these other constraints about psychological profiles of people will have to be also taken into consideration. And which is also why there's like a lot of analog experiences today. There's analogs in Hawaii, there's ones in Poland, and then also in the US specifically for this, because we do know that there are extreme environments, and so I guess the scientists and potentially the workers and the engineers that will be the pioneers first will have to go through those training sessions.
Yeah, the Russians always make long duration crews go camping first, just to see how they get along together, and
happens to waste when human waste when you travel to the moon? I know Antarctica people are meant to bag stuff and return it.
Yeah,
So what would happen with longer term missions?
Yeah, it's a very interesting question. It turns out that one thing that the moon really needs is fertilizer, actually. So, hopefully it's done in a way that's more pleasant than what you mentioned. But it was just, there's got to be an improvement over the Apollo days, which is they would just toss a bag out the airlock. You really have to think about.
There's also the water systems there.
They've been experimenting. Gradually on the space station, they're up to like 85% closed cycle on the water at least, and so they have a lot of purification systems that will do a complete recycle. But I think on the moon, any kind of fertilizer is going to be extremely important to use. It is something where no one wants to go trashing the moon, and that's something where right now there's these discussions on the diplomatic level with the NASA Artemis Accords and trying to get an understanding of how to deal with the moon's making sure that one activity doesn't damage another one. One thing that's interesting about the frozen water at the poles of the moon is that if they are actually samples from billions, back 3 billion years, that Jim Green, the chief scientist at NASA, he is real interested in looking for possible Earth meteorites that have been blown off the Earth, landed in the ice, and been preserved for billions of years, because he thinks that may be samples of when the life was just forming on the Earth, held in deep storage at the poles of the moon. And so it's another science possibility.
So sort of carrying on from that, there's not really much, well, I assume there is a huge amount of work that's gone into minimizing contamination between Moon and Earth.
The original Apollo missions, they were so concerned, about unknown organisms that they kept the astronauts in quarantine isolation after they returned from the moon for 18 days, I think. And the standard idea is that there's on the surface it's absolutely you couldn't imagine a better way to sterilize the surface other than subject it to ultraviolet and intense radiation and vacuum and everything and temperature extremes. And so the only question is up at the poles if those ice deposits actually have you don't want to contaminate those. And there's a recent study about whether or not landing close to them with propellant is going to contaminate some of the samples, and so it's a real active area of research. It's interesting that over billions of years, when objects hit the moon, it blasts pieces of the moon off, and they have pieces of the moon in the lab that have fallen on the Earth and identified, and that they match the Apollo samples, and so that they now understand that those were samples of the moon that have been blasted off the moon and landed back on Earth. And they think it happened the other way too, that pieces of the Earth were blasted and landed on the moon.
Is there any treaty or documents about where people are going to be able to land on the moon?
Yeah, so it's everybody, most like 160 countries agreed to the Outer Space Treaty, which says you cannot cause harmful interference to other missions. And so if somebody has, like when the Chinese have their lander operating, you're not supposed to go down to land and interfere with their lander. And so NASA tried to codify this starting in July, and they issued something called the Artemis Accords. And they said they wanted countries individually to agree to join this, and where we would not cause harmful interference to each other, and we agreed to coordinate our activities and sort of like a traffic management kind of thing. And so some of the countries have agreed to that. There is another treaty called the Moon Treaty, which is only 9 countries have agreed to. And that Moon Treaty really says that the moon is common heritage of all mankind, and you cannot use any part of it without everyone agreeing. And so that was something that the U.S. did not agree to, but the Philippines did agree to. So it may be, it's a lot of active discussion. There's actually, there was one call a couple months ago where people said, let's have about 20 people talk about, how we coordinate this stuff internationally. And 200 people showed up to all talk about this, and so there's a lot of interest in trying to resolve this. So.
And to add to that, as well as that most of those treaties are basically nation-to-nation states, but the problem is that today the timeline for commercial and companies that are going to the moon is actually faster,
Yeah.
and it does not, they're not kind of under those treaties.
Yeah.
So, sort of.
So,
that would be my next question.
yeah.
Like the TV series Mars, when the
Yeah, that's right. It shows up in
Yeah.
it's funny that the conflict shows up in Mars. It shows up in For All Mankind TV series. It shows up in Space Force comedy series. It's funny that it's over and over again. People are talking about this. I'm also working on a chapter with Maria Poza, the space lawyer, about this issue, about trying to prevent harmful interference, because it's only this one or two research groups that have discovered how much interference happens with these landers landing next to each other. And now we have to get all the countries in the world to understand and recognize this. That you can't, all the previous plans, from a few years ago, NASA had these plans of all these missions landing next to each other, and they didn't realize that it's sort of like as though you land and you spray the area with machine gun fire. It's not a polite thing to do.
So they apply law of the seas. So treaties just deal with nation to nation, but commercial operator to commercial operator is governed by the law of the seas. So that's what Maria would have explained.
Yeah. Yeah.
So is it considered the moon to be a testing ground to get everything right in terms of habitation, food, waste, etc. before they do the Mars?
Yeah, and that's NASA calls the whole program Moon to Mars because they want to demonstrate all this activity within like on the moon. If you run into problems, you can launch and come back in a few days. If you're on Mars, you've committed yourself to most of a year before you can come back. And so some people want to just run onto Mars, but I think even the people that try to push for Mars very quickly should realize that the moon is a great test bed. There's slightly different aspects of what, like on Mars, there's a lot more water, ice, and things like that are helpful, and the atmosphere provides some protection, but it's otherwise they're quite similar. Mars has 1/3 gravity, Moon has 1/6. Yeah.
Yes, I think we've used our time. Thank you. You fitted that in absolutely perfectly. And we'd like to say thank you very much for presenting what you've done today, and to think that going to the moon is so close. I mean, I don't know if we really realised how close that is. So you've really sort of opened it up. Who knows how many of us here might make it?
Yeah.
You never know. So please join me in thanking Eric and Emeline for coming on today.